Today on Capechi's Corner, we're going to talk about polynomial functions. We know that a polynomial is written in standard form when the values of the exponents are in descending order. Now, again, we're only talking about one variable in one variable form. We're only one variable when we're discussing these, okay? The degree of the polynomial is the value of the greatest exponent, and we know that the coefficient is that number before a variable. So the leading coefficients, like the line leader, it's the first coefficient. Okay, so let's look at a few examples. We have a constant, which when we just have a number with no variable, so we know that degree is 0. The leading coefficient is 12. We know a linear equation is a line, right? So x is to the first power. That's our highest degree there. And our leading coefficient is 4. We just spent a lot of time on quadratics. That's x to the second power, which would be our degree. And our leading coefficient is 5. And our last example there that we're going to talk about is x to the third power, which is cubic. And our leading coefficient is 8. Now, in our first few examples, it says if the polynomial is in one variable, state the degree and leading coefficients. So in number 1, we do only have one variable. We only have x's. So my degree is going to be to the 5th power, right? That's my highest one. And my leading coefficient is 8. If we look at number 12, we have x's and y's. So we're just going to say this one is not in one variable. And we're not going to be able to take care of the degrees on that one. Now we're going to look at some functions. We have f of x is equal to x squared plus 2x minus 3, and we're going to find f of 3c minus 4. Now you've done this before this year, and in Algebra 1, we're going to square this binomial, which is going to make things a little bit more involved. So I'm going to rewrite that. We have 3c minus 4 times 3c minus 4. And when I distribute that 2, I get 6c minus 8, and then minus 3. Now, I'm going to use FOIL. If you could just do it in your head looking at that binomial, that's fine, but I like to write it out for my students. 9c squared, my outside is negative 12c, my inside is negative 12c, and my last is plus 16. Now, I'm going to combine all my like terms. So I have 9c squared. I'm going to underline that. I have negative 12, and positive 6, which gives me negative 18c. And then I have 16 minus 8 minus 3, which gives me positive 5. So that is f of 3c minus 4 is equal to that value right there. All right, let's keep going. And we have polynomials. We have some graphs here to take a look at. And we're going to talk about whether or not they are even or odd. And we have odd degree functions will always have an odd number of real zeros, which is roots or solutions. We talk about them in the same way. And even degree functions will have an even number of real zeros or roots or solutions, or there will be no zeros at all, which means the function doesn't touch the x-axis. So here are some examples. Right, even, you can see here, this is an even degree that it never touches, that function doesn't touch the x-axis, so that has an even. One thing that you will notice here is with evens that the arrows at the end, right, where we have arrows at the end, point in the same direction. So that's also helpful to us a little bit. So in this one, the arrows are both pointing down. In this example here, they're pointing down as well. If we want to see or double check, it's touching the x-axis there. That's 1, 2, 3, 4, which is an even number. So we know that's an even degree polynomial. Okay, when we are looking at odd degrees polynomials, again, this time the arrows are going to point in opposite directions. One will start down and the other will go up, or vice versa. We can see in this first example that it touches that x-axis 3 times, which is an odd number. And in this next example, we can see that it touches 1 time. Okay, so that's even and odd degree polynomials. Okay, let's look at some end behavior of polynomial functions. So as we're end behavior, we're going to talk about whether it approaches positive infinity and negative infinity and what happens to that f of x. And we're also going to talk about the degree and the leading coefficients and their relationship with the end behavior. So let's look at the first one. So as x goes to positive infinity, right? Positive infinity, that would be going this way. My f of x is going up, so that's also with the arrow on the end there. I know that value is going to keep going up. It's going towards positive infinity. Now, as x goes to negative infinity going this way, in this case, in this graph, f of x is also getting higher, so that's positive infinity as well. That's where it's going. Now my degree here is a 2. And my leading coefficient we know is going to be positive because we're paying attention to what's happening to my f of x towards the end behavior. All right, let's take a look at our next example. So in this case, my as x approaches positive infinity, which would be this way, then I notice that f of x is approaching negative infinity, right? It's going down. And as x approaches negative infinity here, as it goes this way, it's f of x is going up. So that's going to be positive infinity. My degree there is 5. My leading coefficient, I know, again, it's going down. So my leading coefficient is going to be negative, and I can see in this case that it is negative by the equation in the graph. Okay, so let's try a few. So we're going to kind of put it all together. We're going to say describe the end behavior, determine whether it represents an odd or even degree polynomial, and state the number of zeros. So let's look at number 1. As x approaches positive infinity, then f of x is approaching negative infinity, right? It's going down here. As x approaches negative infinity here, f of x is also negative infinity. Okay, my arrows are pointing in the same direction, so we know this is an even degree. You can also double check because it's touching my x-axis twice. I'm sorry, it's touching my x-axis, my zeros twice, and the number of zeros here is going to be 2. That's specific asking how many. All right, let's look at our next example. So as x approaches positive infinity, f of x is staying towards the negative end, so it's going to be negative infinity. And then as x approaches negative infinity going this way, this time it's positive infinity, right? That values are going up. Okay, because my arrows are going in opposite direction, it's an odd degree polynomial, and the number of zeros, we can say it hits 1, 2, 3 times. So that's the number of zeros. Okay, and that's it for today. Listen, great job. I hope you have a good one.